Okay, here we are on a math board, which I kind of need because not everyone may understand how or why I'm doing some of these calculations. So let's get right into it because I want to keep this short. So in the first place, I just described what a lumen is. And a lumen is, you think of an imaginary sphere around, let's say, a candle that's got a 1 foot radius. So the total surface area of that sphere would be 12.5 lumens. Get rid of the half because of the shadow of the candle body. So you basically have about 12 square feet in this sphere. There's 1 lumens per square foot from our standard candle. And so this candle is putting out 12 lumens total. So for example, a 16 watt LED, which is equivalent to a 100 watt incandescent light bulb, puts out about 1600 lumens. A 55 watt LED street light, about 5500 lumens right there. So lumens per year is just typically, if you're operating 4,000 hours a year from dusk till dawn, that's the total amount of lumen hours that a fixture would put out operating over 1 year. Half the night, as I said, was 2,000 hours. So I give this examples here. 16 watt LED, 1600 lumens, x 4,000 hours, 6.4 million lumen hours per year. And 55 watt LED street light, 4,000 hours a year, 22 million lumen hours per year. And again, as I said, 1 million lumen hour packages are equivalent to 250 lumen light bulb for 4,000 hours a year. And then I described the first half of the night here. Installed lumens is the total lumen hours. Let's say over 4,000 hours. So, for example, if you have 22 million lumen hours that you're allotted, over 4,000 hours means you can install 5,500 lumens. We're just working the math backwards here. Holiday or seasonal lighting is 31 days from December 4th to January 4th. It's 11 hours per day, 100-foot strings, 2 feet apart. For the light bulbs, 12 lumens each, 600 lumens, x 11 hours, x 31, so forth, which is 0.2046 million lumen hours. So the total, this is CCT right here, which stands for correlated color temperature. CCT of 3000 Kelvin is considered to be warm light. And temperatures above 3000 Kelvin are considered to be cool white because the light is blue weighted. Typically 4000 Kelvin light have 2 times the amount of blue component of light in them. The total electrical load for all outdoor lighting in a city of 100,000 runs from 2.5 megawatts for the second half of the night operation to 3.5 megawatts for the first half of the night operation. Average of all such lighting would be 12 million kilowatt hours, costing $1.3 million at 10 cents a kilowatt hour per year. Now, the final thing I describe in the math is, and this is the kicker, if every household, 33,000 households, let's say, charged 1 electric car per household at a peak of 28 kilowatt hours per car, and that includes the 15% charging losses, it would roughly equal a load of 0.933 gigawatts times 5 days a week times 52 weeks or 260 nights a year, and that would amount to 242.666 million kilowatt hours, which amounts to over $14 million a year at 6 cents a kilowatt hour. Now the reason I mentioned 6 cents instead of 10 cents is that's an electric rate you can get for off-peak charging for electric cars currently in Las Cruces. And it's a good idea, and I'll explain that in a second. This power use makes much more sense for balancing electric utility load factors than outdoor lighting ever could. And you can see why. It's by a factor of 16 times more than outdoor lighting is in this instance. So if the utility really wants to balance their loads at night, do a better job of it, they would promote electric cars and not outdoor lighting. Outdoor lighting has been overutilized for too long to the detriment of the night sky and the environment, human health, and so forth. In other words, what I'm trying to point out here is one of the reasons we see so much outdoor lighting is the electric utilities promote it, and so does the lighting industry. And it really needs to stop because it's all counterproductive. All it does, the more lighting you use, the eye just adapts to it all, and the pupil shuts down, and so it's just wasted power. And it could be much better utilized. This kind of power could be better utilized to charge our transportation fleet than it does outdoor lighting, which is very small in power use anyway when it's done right. So I'm going to let it go here, and we'll give this one a separate title, and it'll follow the first video on YouTube. Thank you very much. Bye.